Hello students of ninth class. Today we'll discuss about part of motion. Last lecture is physics lesson. Distance time graph for a linear uniform motion. First of all, uniform motion means if an body cover equal distance in equal interval of time. Okay. Now and body will just move straight line. For uniform motion along a straight line, the distance time graph is a straight line inclined at a fixed angle with time axis. Here you see that angle is always fixed. Time axis and distance, that's x and y axis. Okay. If an object is uniform motion along a straight line, then it covers equal distance in equal time. As we know, in uniform motion, object covers equal distance in equal interval of time. Okay, that is the graph states. Here, straight line means uniform motion. Okay, here in 10 minutes, that is 10 kilometer. Next 10 minutes, also 10 kilometers. Okay. Now determination of speed from distance time graph. First of all, uniform speed, that is distance by time, and here diagram again. See in the diagram as we see last page, QR by PR. I show again you QR by P, that is distance and that is time. Okay. Now S2 minus S1 and T2 minus T1. Okay. Here you again show S2 minus S1, S2 minus S1 and T2 minus T1. Here T2, here point T1. Okay. Now here from reading we get, but ratio QR by PR is the slope of given distance time graph. The slope of distance time graph gives speed of moving object. Okay. That is distance by time. Distance is 30 meter and time 40 seconds, means 0.75 meter per second. That is the graph for straight line, means uniform motion. Now we discuss about non-uniform motion, when an object moves in non-uniform motion. Okay. Now graph may be of any shape, curved. Okay, means not in uniform motion. Here show velocity time graph for a non-uniform motion. Okay, here for uniform motion, first see you graph here. For uniform motion, velocity of the object do not change with time. So velocity time graph is a straight line parallel to time axis for uniform motion. Here uniform motion. Okay, here that is for uniform motion, means here only straight line, means velocity fixed here, do not changes but time changes. Okay, that is for uniform motion. Now determination of distance covered. In a velocity time graph, distance covered or magnitude of displacement is given by the area enclosed by velocity time graph, means area enclosed by this graph, that is you see here PS into SR, that is area of rectangle PQRS. Now that is the most important topic, first equation of motion. Here time axis, velocity axis, up to here that is u, initial velocity. After that start velocity v. Here u, and that is v. Okay. Velocity time graph for uniform accelerated motion along straight line. It is straight line. It is a straight line. Point P corresponds to initial velocity u at time t is equal to 0, and at point Q, here at point Q corresponding to final velocity v, means here u then change into v. Now draw QT perpendicular OT, QT perpendicular on this line, RP perpendicular OS, RP perpendicular this line OS. From the graph, QT is equal to V. Here QT is equal to V from this here, and PO is equal to RT. PO is equal to RT, that is equal to U. Now from here QT is equal to QR plus QT is equal to QR plus RT. we get v is equal to qr plus u. Now qt, here v, qr plus u, rt is equal to u, and qr v minus u. Okay, here. Now uniform acceleration of an object, change in velocity by time means qr by rp, and qr by ot from diagram as shown in this side. Now a is equal to v minus u by t, ot is equal to t, and qr is equal to v minus u. That is, from this we get last point, v is equal to u plus at. That is first equation of motion. Now second equation of motion, same diagram is there. Here we get distance traveled is equal to area of OPQRT. OPQRT. In this, one rectangle and one is triangle. Both area we plus add area of rectangle OPRT plus area of triangle PQR. Rectangle this and triangle of area of triangle this. This we get OP is equal to U, PR is equal to OT, that is T. Or QR, that is from first equation, V minus U is equal to AT. Now put in this value, UT plus half AT square. That is the second equation of motion up to this. Now also third equation of motion, same diagram is also there. Okay, but here distance traveled is equal to area OPQRT. That is trapezium, this side parallel and this side non-parallel. Okay, that is the formula, sum of parallel distances by 2 into distance between them. OP is equal to U, QT is equal to V, and OT is equal to T. By putting the value, distance traveled is equal to S is equal to area of trapezium, OP is equal to U, QT is equal to V, and OT is equal to T. This putting value we get from first equation, AT V minus U, that is T is equal to V minus U by A. By putting these values here, V plus U or U plus V and V minus U by A, that is A minus B, A plus B. A square minus B square, V square minus U square, that go there. V square minus U square is equal to 2S. That is third equation of motion. Okay students, in the next lecture we start force and laws of motion. Till then, stay with us. Thanks.